Hello everyone and welcome to this coding challenge. In this fifth coding challenge, I'm going to be making an After Effects Easy Key plugin, which hopefully will consist of a color input as well as a threshold to control how similar of colors to select and key out. This is going to be a purely After Effects plugin, so hopefully it's going to be one of the more quick ones, but maybe not. We'll see with this video. Before we get started, I do want to remind you down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel, and down in the description you can check out the code for this in the GitHub link, try it out for yourself, or just use the plugin. And you can follow us there for coding updates, and in the description follow us on Instagram for other updates. You can also join our Discord server, link in the description, to get help with scripting, extensions, plugins, expressions, and much more. And of course, you can join our YouTube channel as a member, supporter, premium supporter, or VIP, get cool perks, and help us out financially. So the idea behind this plugin is we're going to have two simple inputs. We're going to have a color selector, like most plugins that Key do, as well as a simple threshold slider, anywhere from like 0 to 100% threshold. And I think at 0% it will just be purely that color, say for example green. As you go to 100%, we'll increase the amount of colors similar to that green color, we could say in this case. Those will be the extra colors we select. So the first thing we need to do is set up our project. I'm going to just copy and paste a different project and then replace the values inside. And because I want this to run in 8, 16, and 32 bits per channel, I'm going to need to make sure we use Smart Render. And my particular skeleton does not really support Smart Render that well, so I'm going to use one of my other projects and just modify that. I have this here Zebra plugin. I'm just going to copy and paste, and I'm going to start by changing the name to Easy Key. I think that will be the name of the plugin, is Easy Key. And now I'm just going to go into the project and we're going to need to change everything up. So I'll launch Visual Studio as an administrator, and I'm going to go navigate to that folder, find my new Easy Key folder, open up the project, and now we need to go through and modify everything. All the values in this are according to a Zebra, and we need to change that to be Easy Key. So I'm just going to go through here. Our project name will be Easy Key, and we're going to keep it at, I think, one word. That way we don't have any space issues. And anytime I see Zebra, I'm going to change it to Easy Key. And we have strings here, which we may use, we may not end up using. It just depends. Usually if we have a lot of UI elements, you'll want to make those changes, but in this case, if we're only going to have a color input and a threshold, it may not be necessary. So just a couple more files here to change the name of. Easy Key, Easy Key. And then we also have all the includes and stuff we need to take into account. So I believe Control-Shift-H to replace in files. We're going to make sure we match the case. We're going to replace Zebra with Easy Key. Replace all of those. We'll replace all caps Zebra with all caps Easy Key. And I think that should be good for now. Now we need to kind of go through and adjust our R file, which contains like the match name and what kind of other properties it's going to have. So the name of it's going to be Easy Key. We'll make it a space in this case, because that's the display name as we apply our plugin. I'll keep it under NT Productions for category, and we'll just do NT Key for our match name. And let's go into our main CPP file. Actually, let's go into our header file. We'll take a look at our structure here. Instead of these values, we're going to need a color and a threshold. So we actually are getting lucky here. We just need a threshold and a color. And then for our structure, we don't need all these. We just need a threshold. And then, yeah, I guess we'll need a color 8, 16, and 32. So luckily this particular effect that I've already created that I'm copying to use is going to help us out quite a bit here in terms of saving time. Let's go ahead and just run a first build and see what errors we get. So the first thing is we need to adjust our parameters or the displays in our plugin. We'll just have first we'll have our key color, which by default let's set to green, like a nice bright green RGB. And then we'll have the threshold, which I don't want to actually be a float slider. There is a type of slider that's sort of a percentage. So I'm going to say, let's see, I think I can just type in like slider X. And we want to add percent, I believe. This is the code we want. So let's say, let's do this here. pf underscore add percent. And it's going to take a name, which we're going to say threshold, the default, which we'll set to 0, and the ID is going to be our threshold disk ID. Then we'll get rid of the previous one, get rid of this other property we don't use. So now we have our color and our threshold. We need to go down to our pre-render and make sure that we're checking these out properly. It's actually going to be in Smart Render. We need to check out our color and our threshold. And those are already all set up nicely because we did a simple batch replace of the names and we just happen to have those properties from last time. Now we should have some use of the thickness here we don't need. And let's see what else we got. We don't need any instances of thickness. We're just going to go through here and make sure all of these values are valid and matching. We don't have anything called spread. That's fine. We're just gonna trim that out. Get rid of any of the code that's going to cause issues. We just want to compile this first thing and make sure we can test it out. All right, succeeded. Now let's go into our properties and make sure we're building this in the right place. And for debugging, we're running in After Effects and everything looks good. Let's go ahead and F5 to launch this. Oh, I think we're trying to build as release. So let's build as a debug version. And now we should get the program to launch. For a second, I thought that was running as admin error, but it looks like it's just building and release error. So make sure you start with debug. You only want to debug in debug mode. You don't want to debug in release mode, otherwise you'll obviously get errors. So we're also going to need some test footage. I don't know that I have any. Let's see. I think I have some random video that might have green in the background, but I think it's a fluctuating green. So, here's what I'm gonna do. I'm gonna take a clip, I'm gonna apply Colorama, and we're gonna make it super green. Try ramp green. And that might be too much of a tint green. Let's use a hue and saturation maybe to tint the blues just over to be green. This way we can basically make it 97. This way we can have something to work with maybe. These are quite yellow. That looks like a good green. So let's go ahead and pre-compose this. And if I was to say apply key lights, that should appear like it's a normal thing we're trying to keep. So this is going to be our test footage. I might actually even, let's increase the saturation a bit. And we're just going to like pre-compose this and then save this as our test project. So we'll make sure we're in whatever bit rate we mainly want to test in. We'll do 32 bits. We'll save this and I'll just call it easy key test. Now, we go down to NT Productions and apply easy key. you can see we have our key color and our threshold, which is perfect. So we're going to allow the user to select whatever color they want to key out, and they can eyedrop it as well from in here. And we also want to say if the threshold is 0, it needs to be exactly this color to be keyed out. And as we go towards 100, we're going to have some space where if the colors are similar enough, it will actually select those. So now we need to go ahead and figure out how we're going to do that. We already have some functions set up, so let's take a look at those. Let's go back into Visual Studio. We have our easy key function 32, easy key function 16, and easy key function 8. Currently, they're producing a black screen, as you can see, which is completely transparent with no color. And this is because we stripped out all that code and we're going to do it from scratch, basically. And the way these are running is just in our actually render. If you're not familiar with smart rendering, inside of our calls here in our effect main, you sometimes have just a render function, which is fine for like 8 bits per channel. But if you want to use 32 bits per channel or use the smart effects features, which save a lot of memory and processing speed, and reuse memory, in fact, we use the pre-render and the smart render functions, which simply do a thing called variable checkout, where we check out our variables before we go into do all of our code. And then in our actually render function, this is where we detect what bitrate we're in. We have our 32, 16, and 8 bits per channel options here, where we just do an iterate function, which goes over each pixel. And for each of the pixels we check, we're going to want to check some conditions, like if it's green or whatever the key color is. So conveniently, because our previous project I copied here had a color and a threshold option, these are already sort of integrated. So I have in my H file, we have a constructor here which creates this easy key info type, which contains a 8-bit color pixel, a 16-bit color pixel, a 32-bit color pixel, and a threshold information holder. These are all read directly from our interface here. So we have a variable we create called color8, and this takes the color value from our color effect here. It'll take the key color effect and put that into this variable. Then we convert it to 16 bits and convert it to 32 bits, which I already had defined for our 16 and 32 cases. And then for a threshold, we simply grab the slider value of our threshold, which I believe an fs_d is for a float slider. So let me double check here if I can find. Pretty sure fs is for a float slider. Is there a specific one for the other kind? It kind of is a fixed slider, so let's do that. And now what I'm going to do is set my actual constructor that I just temporarily created. If you're not familiar with these setups, check out the previous plugin tutorials. But basically, we fill in the values of our constructor we created. We create a new constructor, a new object, which is going to contain all of our input data, and we send that into our iterate functions. So to make sure these are valid values, I'm just going to set a breakpoint right after we set these up, and I'm going to restart my my plugin. Looks like we got an error. So it doesn't like fs. I guess let's continue with FSD, and if it gives us the right value, that should work just fine. We're just going to make sure that these are populated with the correct values. The color 8 should read that it's a green color by default, and the threshold should read 0 by default. So now when our project loads up, we can simply wait for the home menu, select easy key testing, and apply our easy key. Color 8, you can see we have alpha is 255, red is 0, green is 255, perfect. And to make sure our color conversions are accurate, you can see we're getting just green as well. And for threshold, we have 0. So these values are coming in perfectly. Now all that's really left to do is create the function to detect which pixels to key out and the threshold. So first, let's do just the straight up key. If the color is equal to the same pixel values as the color that the user selected, then those need to become completely transparent. So we're going to start off with a 32-bit function. We'll go into there, and we don't really need this luma value right now. We're going to start off by grabbing our information from the color that they selected. So I have here a ZIP, which previously was for zebra. Let's just use KIP to represent key pointer. And what I'm going to do is say KIP dot color 8, or this is 32, my bad. So we need to grab pointer to color 32, and we need to check if the, I don't think we need to check if the alpha is the same. We just need to check the RG and B. So what I'm going to say is if our in pixel dot red is equal to KIP dot color 32, or pointer to color 32 dot red, and then I'm going to do the same for the other channels. So if the input red is the same as our, and this is the input pixel, by the way, not the input value. The input pixel is MP, and the input value is the one selected in the UI. So we're going to check if the red channel on that is the same as that. We're going to check the green channel, and we'll check the blue channel. We don't need to check the alpha. Maybe we will in the future, we'll see. If all three of these match, then we want to say our out pixel red is equal to 0, our out pixel green is equal to 0, our out pixel blue is equal to 0, and our out pixel alpha, most importantly, is equal to 0. If any other case is met, then we just want to use the input values. We don't want to change the pixels at all. So I'm going to say copy and paste these and change them to NP red, NP green, NP blue, and of course alpha, NP alpha. Now, theoretically, if I run this, if I select the exact color required to key, it should become transparent. And the way I'm going to make sure I do that is simply by color picking whatever color I want. If this works successfully, we can move on to the next step, which is including the threshold, which we do have to get a little bit creative. How are we going to detect if an RGB value is close to another RGB value? So first, let's go ahead and run this. Easy key. And as you can see, it started off blank there because we loaded in a previous cached frame. If you ever just notice some weird behavior, make sure you purge all memory and disk cache. And now I'm going to color pick this color, and we can see nothing is happening. Let's go ahead and set a breakpoint and check our values. So the NP colors are going to be a little bit different. Oh, I'm using color 16. I didn't even notice that. These need to be color 32. And I think that should be good enough. Let's check that again. Remove the breakpoint. And hopefully at a certain point we can just use the shortcut Control-Alt-Shift-E to apply the last effect, which is our effect here. I think we need to close it in After Effects. So easy key. And turn on transparency. We got nothing. Let's color pick. Still nothing. Okay, let's go back to our breakpoint. Let's see if we ever get inside of here. Nope. I think we're missing something simple. So our MP coming is that. Color red is that. So these values are quite specific, and it's going to be hard to ever find a match. So, I think what we need to do is make it a little bit more complicated. We can't just say, are these color values the exact same? We do probably need to include our threshold now. So I'm going to say, let's say PF FP long threshold is equal to our KIP. We'll grab the threshold. Again, this is going to give us, I believe, a value from 0 to 100. And let's say if it's 100, let's add up all the colors. So if we add up the RG and B channels, we're going to get a total value of 3 at our max, a minimum value of 0. So if we had a full white color, our R would be 1. Sorry, our R would be 1, our G would be 1, and our B would be 1, giving us a total sort of luminance of 3. So let's calculate our total luminance. I'm going to say PF underscore FP long luma, and we're going to set this equal to our color 32 dot red plus our color 32 dot green plus our color 32 dot blue. Now again, this will give us anywhere between 0 and 3. And this is our, let's have 2 lumas, so we can just compare the 2 lumas instead of having to compare RG and B. We'll simplify it. So this is going to be our key luma. This is like our desired luma that we're looking for. But we're also going to have the luma of the input pixel. So PF underscore FP long input luma. This is going to be equal to, very similar, but instead of KIP, this is going to be NP. And dot red. This needs to be a pointer. And now we have our input luma and our key luma, and we can compare these. Instead of having to check if the R, G, and B values are all similar, we can kind of guess it based on how bright I think it is. We may want to go into more depth by saying, well, if it's the green channel that has the most intensity, we only want to check that channel. But now for our threshold, remember it goes from 0 to 100. Let's make that plus or minus 1. So if the luma is plus or minus 1, then that's what we want. How am I going to do this? Let's see. Let's set our threshold. So let's say our threshold is 100. Let's say they set it to 100, the max spread we want to search for. We want the max threshold to end up affecting it plus or minus 1. So we can simply say threshold times equals times it by 1%. So if they have 100, if they have 100, it'll be 1. And if they have 0, it'll be 0. If they only have 1 for the threshold, it's going to be a very small amount it's going to look for that are similar. And the way we're going to check if it's similar, I believe we need 2 conditionals. Let's say, is this actually working? Okay, cool. Let's say if I'm gonna have this or this. I have two cases. If our input luma we're gonna need like a lower and an upper luma bound. So okay, we're gonna have two new variables. Let's have a upper luma bound and a lower luma bound. The lower luma bound is going to be equal to our key luma minus our threshold, and our upper bound is going to be equal to our key luma plus our threshold. We also need to clamp this, so if our lower luma bound is less than 0, we want to set the lower luma bound equal to 0 so we don't get any weird results. And if our upper luma bound is greater than 1, then our upper luma bound needs to be equal to 1. And then we'll say if our input luma is greater than, actually, I think we just need one statement. We don't need to enclose this completely. If our input luma is greater than our lower luma bound and our input luma is less than our upper luma bound, then key it out. Let's see if this works. I'm going to rerun this. I think this should get us a closer result to what we're looking for. We need to not be so specific because at least in 32-bit float, there are so many decimal points, and if you're searching for exact matches, you probably aren't going to get it. So we'll launch and go to a new frame, apply our effect, and we'll select a color. As you can see, we're not getting any results. Let's go ahead and add a breakpoint and see what our values are coming in at. So our threshold is at 0. So one thing we want to do for now probably, let's change our threshold default not to be 0 because that can obviously be a bit confusing. Uncomment this, and our threshold by default 100. And let's try that. And hopefully, fingers crossed, we'll get some kind of result that we can then build off of and refine it and then apply it to the other ones. And if it's fast, then that's good because it's supposed to be easy and fast. So apply our effect. And we're still getting nothing. Let's go ahead and apply a breakpoint and see what issues we can find. So our threshold is coming in actually at quite a strange value here. This is what I was slightly concerned about using a percentage slider. Yeah, it's giving us a really strange value. Our upper and our lower luma limits are looking really good, but I think the threshold is what's throwing us off here. So let's go back to the guide really quick. And I'm trying to find, I need to make sure that I'm getting the right value here. So when I'm calling fs_d, I don't know if this is correct. or param def. And which one do we need to be using? Fixed slider def? Slider def? Let's try slider def. Can often be wrong saying these things in plugin development, but hopefully if once we get our threshold value to be valid, we need to also set a breakpoint. Once we make sure it's valid, then it should be working. If not, another bug hunt basically. So this time when I close it, I'm going to close it out of After Effects because I think it will remember my last effect I applied. Apply easy key. Our threshold is coming in at 65, a big number. Okay, so that's not going to work. Instead of SD, let's try a different one. The last one is FD for a fixed slider def. And if this doesn't work, FD does not work, then I think what we're going to have to do is use a fixed, or no, sorry, a float slider. Which is totally fine, it's just, it'll be, I guess we can clamp it anyway. We can clamp it to an integer between 1 and 100, or to a float or something more manageable. That's probably one of the bigger issues experienced when making plugins, is making sure the different bit rates are going to work together. I don't think I closed the program like I said I was going to. Now what are we going to get? A huge number. So let me try one thing. If we try and clamp it maybe? No, we shouldn't try so hard. We should just make a float slider. So we'll go up to our params, wherever those are. And let's do pf_add. We're going to add a float slider x. And we're going to need some information like our threshold, the valid min, 0.0, max 100.0, min 0.0, max 100.0, default 100.0, precision, we're going to use pf_precision integer, display flags, ID, threshold, disk ID. I think that should work. And now, instead of FD, we're going to get fs_d. And if this doesn't work, I will try casting the value, but I'm hoping this will come in more accurately. All right. Load it up. You can just type in what easy key. Threshold is coming in at 100. Our lower bound is 0 and our upper bound is 1. Do we get any legit results? We gotta get rid of the breakpoint. Oh wait, no, we are. If we look in really close, you can see we're getting the tiniest bit. So maybe if I select a more color like this. Okay, so that's kind of working. But it's a very small portion that's being keyed. So let's check here. Our lower luma bound is 0.47 and our upper is 1. And our key luma is 1.4. Input luma is 1.6. So 1.6 is greater than 0.47, yes. Is 1.6 less than 1? No. Yeah, the thing is 1.47 plus 1 should not be 1. That's, I think, our issue in this case. 1.47 minus 1, however, is of course 1. So it's interesting that's not working. Let's close out of this through After Effects. Oh, we got to get past the breakpoint. It seems to be our upper bound only that's messing things up here. We'll close. And let's look at the data types. We have an FP long plus an FP long. That should work no problem. We said if it's greater than 1, we need to clamp it to 1. That's not true. If it's greater than 3, we need to clamp it to 3. Fingers crossed now. We should have a much more aggressive key. And the goal of this isn't necessarily to be like the craziest accurate key. It's more just to be like fast and like two options. You got your color, you got your threshold, boom, you're done with your key. Now we should be able to, yep, Control Alt Shift E, and boom, we got our key going here. Let's select more specific color. You can see we're getting some nice results. Maybe we should have picked something with actual green screen. I have some clips with green screen in the background. It's just the colors flash. So it would be a single frame that we can check. So, okay, click on maybe a little bit darker of a green. But you can see the color is conflicting here. Because we're using luminance, the colors are having a bit of an issue. So, the way we're going to get around this is we need to find the important channel. We need to find what channel has the most intensity. So we're going to say var I guess this is in JavaScript. We're not going to say var. We're going to say bool r important, g important, b important. And now we need to like find what is the most important channel to check on. So we need to grab like the max of our, we need to grab the max of the key color or the import. I guess they're the same. We need to just identify what the most important channel is. So let's say np, no, it needs to be our key color. Compare the red channel, this, to the color 32.green. And then we need to do the same between the green and the blue. And does this return a value? Yeah, let's say I'm struggling in my mind a little bit to think how to select them. I'm gonna do it like this. If KIP color 32.red is greater than KIP color 32.green are important is equal to true. I'm going to set all these to false by default. Just like this. And actually, so let's by default say R is the most important. If R is less than our green channel, then G important needs to be true. And then we'll say if our green color is less than our blue color, then B important is equal to true. I don't know if that covers all the cases. What if R is same? If the blue channel is greater than the red channel as well, then B important is equal to true. Other than that, I think that should be accurate. So now we need to calculate the luminance based on that channel. A little bit more complicated. So we'll say, we'll have these defined. And we'll say if R important is equal to true, I have a case if B important, I guess that should be G is equal to true, or if B important is equal to true, and we'll change this up here. I believe, no, we don't, because that's actually checking for the blue. If that's the case, our input luma is going to be according to our red channel. If it's G, our input luma is going to be according to the green channel. And if B is true, it's going to be according to the blue channel. So that'll give you just the channel we need's value. And then same for key luma. Needs to be set to the appropriate channel. And blue. And now maybe it will be more focused on one channel. So let's say it detects that green is the most important channel. Is the red channel less bright than green? No. Or yes, it is. So G important is true. Is green less than blue? No. So after all this, G important will be true. And since G important is true, our input luma is going to be based on our input pixels green, and our key luma is going to be based on that green as well. And then we simply are going to compare them. Let's try it out. I wasn't expecting to have to take this kind of workaround, but it does make sense. We can't just use overall luminance because that doesn't quite account for how color and RGB works. And we'll load up a clip. As you can see, we seem to be getting more strictly green values. Let me get an actual green screen piece of footage. I'm gonna have to download this, don't I? Do I have any green screen footage myself that I could pull out really quick? I don't know. We are strapped for time. we are quick, maybe we can. I'm not sure. Got some videos. I don't know if there's anything raw in here that has green screen. Not thinking so. Let's just, oh man, this is like interlaced too. And it's, okay, that's not gonna help at all. I have to use that previous clip, like this one. I'm gonna clear my cache because the first couple frames, it was already cached in there. And now, as you can see, it is actually working a ton better. Our sensitivity is not killing the green here. And I could probably select our red here and just key that out. So now all that's left to do is update this for the other functions, which is super easy here. I'm just gonna copy and paste from my threshold down to my else. Paste here. And let's see, we need to change all the color 32s. Why is that? Okay, yeah, this needs to be KIP. Instead of 32, it needs to be 16. And then we'll paste the same into the 8 bits per channel. And this is going to be different. Instead, it's going to be 32768 times 3. It's greater than that. We'll set it to that. That's just how the Luma is going to be working in that. I don't actually think we need to do that because, we are not adding up all 3 for the Luma anymore, but we'll continue here. Go on to our 8 bits. Change color 16 to color 8 in all instances. Change this. Color 8, color 8, color 8. And 255 times 3 is our max in this theoretical case, if that is ever reached. This needs to be KIP. KIP. Alright, let's try it. We'll try in each of our bit rates, and if it works, we will call this good for now. And you can test it out on any of your footage and start adjusting it yourself. It'll be a nice or sort of skeleton keen project for you to start on, but it is actually working the way I really intended it to. So let's bring in that same piece of footage we used just now, because it has a nice example of multicolors that we can try and separate. Go to 8 bits per channel, apply our plugin, pick the green or the red here. Looks like we might have an issue with that. I think it's our threshold. Let's try 16-bit really quick. I think it has to do with our threshold. Threshold's coming in at 100 times that. Color green is less than color 8. Wait, am I comparing? What am I comparing here? Okay. Really quickly, see if we can figure this out. Color, that's the important channel. If R is important, the input luma is equal to our red. Our key luma is equal to that red. Same for green and blue. Our key luma in this case. Okay, so in this case, we need to multiply, I think, this by 255. And in this case, multiply our threshold by 32678 or whatever the value is, because we were using our 32 bits, value, which is 0 to 1. So we need to expand this out even more. So I'll go ahead and Load up my project. I'm going to clear the cache really quick because the first couple frames again were undesirably cached. Apply plugin. Try red. Awesome. That actually, look at that. Look at that key. Look at that key. Look at that key. Look at that key. Alright guys, that's going to do it. That is our easy key plugin finished. Now you can go try it out for yourself, make adjustments, or just use it nice and fast and use it as a starting point for other cool things. If you enjoyed the video, hit the thumbs up button. Down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly on the channel. And down in the description, be sure to check out the code for this in the GitHub link. Follow us there for updates on code and just check out the other stuff we've uploaded. Also in the description, follow us on Instagram for other updates. If you want to get more help outside these videos, join the Discord server. We have scripting, extensions, plugins, expressions, channels, and many more. And if you want to help support us on YouTube and get cool perks at the same time, you can become a member, supporter, premium supporter, or VIP. Link in the description. Thanks. I'm going to leave that in. But thanks again for watching. We'll see you guys next time.